Okay, once again, good evening, everyone. So let's continue with where we left off last time, which was factorial. So here are some examples of factorials. Let's say 3 factorial, which is going to be 3 times 2 times 1. 4 factorial is going to be 4 times 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. And in general, n factorial, n is a positive integer, let's say, is n times n minus 1 times n minus 2 times 3, 2, and 1. So n factorial is the product of first n integers, 1 through up to n. That's what it means to find factorial. Now, as I told you, for factorials, please don't do things like this, like 12 factorial divided by 6 factorial. Do not cancel 6 and 12. It's incorrect, okay? You don't do that. That is not right. Or you cannot add 5 factorial plus 6 factorial, which is 11 factorial. No, please don't do that, okay? Or you cannot multiply the factorials or subtract the factorials. You have to simplify it into this format, okay, or this format, the same thing. And then you do the regular operations, arithmetic operations that you had. So having said that, let's just start off with an example that would help you. Oh, one more thing, very important. 0 factorial is defined to be what value? What is 0 factorial equal to?
0.
Okay, good. Anybody else wants to try?
1.
0 factorial is 1 by definition. 0 factorial is 1. All right, so now let's go ahead and clean it up. Let's simplify this. 20 factorial divided by 16 factorial times 4 factorial. We need to simplify it. We can unroll 20 factorial this way. 20 times 19 times 18 times 17 times 16 factorial, right? Because it goes all the way. Why do I go down to 16? Because there is a 16 factorial there. So this is going to be 16 factorial times 4 factorial is 4 times 3 times 2 times 1. So 16 factorial cancel out. And now let's see. 3 times 2 is 6, right? 6 goes into 18 3 times. 4 goes into 20 5 times. So if you simplify it, you're going to get 5 times 3 times 17 times 19. So 5 times 3 times 17 times 19 is going to give you 48, 45, okay? So this is going to be 48, 45. And this is how you simplify a some expression involving factorial. However, keep in mind, this is kind of a standard thing that's going to show up when we talk about permutation and combination. That's why I'm giving you this example ahead of time and get you prepared for those kind of examples. All right. So having done this, any question, anybody? Is everyone feeling okay with it? Can you handle similar problems?
I think I have a question based on the denominator.
Yes,
so
please.
We thought it was 16 factorial. Well, what if like the 4 was in front of the 16? Would it matter the order? You would take the largest number for it to be like the factorial at the top?
So if I understand your question correctly, if I had the 4 here, right?
Yeah.
That wouldn't make a difference because 16 factorial times 4 factorial is the same as 4 factorial times 16 factorials. Okay.
Yeah.
So in that case, it doesn't matter. Now, well, in either case, it's the same thing. Now look, 20 factorial, we want to go down as far as possible so that we can cancel the biggest term in the denominator, which is 16 factorial. And that's why we went down to 16, not to 4. Okay?
Yeah, I got it. Thank you.
Mhm. Any other questions, anybody?
Oh, you can go first. Sorry.
I was just gonna ask that. So, for example, like the 20 to 5, that's like what, like 4 goes into 5, and then the 18. How do you get to 3?
Because 3 times 2 is 6, right? 6 goes into 18 3 times.
Mm-hmm.
See this 3 and 2 multiplied together here.
Oh, okay.
3 times 2 is 6, correct? I just combined it. So 6 goes into 18 3 times because 6 times 3 is 18.
Oh, okay.
Are you sure?
Yeah.
Okay. Who was the other person trying to ask question?
I actually had the same questions. You answered it.
Oh, okay, great. Thanks.
Can we do one more example?
Yeah, that is the next thing I'm going to have you do. So go ahead and do this. 14 factorial divided by 10 factorial times 4 factorial. Everybody go ahead and work on this. I'm going to leave the above example so that you can see and work on it. So everybody please take a minute or so to simplify it and then give me the final answer. And of course, I'll do it after you try it. So how are you guys doing? Have you gotten any answer for me?
I'm still working on it.
You're still working on it?
Yeah.
You need a little bit more time?
Yeah, just a little bit more time.
Okay. All right, so let's go ahead and simplify it. 14 factorial, we are going to go down to 10 factorial because the biggest number in the denominator is 10. So it's going to be 14 times 13 times 12 times 11 times 10 factorial divided by 10 factorial times 4 factorial. But 4 factorial is 4 times 3 times 2 times 1. 10 factorial and 10 factorial cancel out. And then let's see what cancels here. 4 and 3 is 12. Look, this is 12. And this 12 and 12 is going to cancel. 2 will go into 14 7 times. So you're going to have 7 times 13 times 11. 7 times 13 is 91, right? Times 11. That's going to give you 91. 10 is 101, I think. Is this what most of the people got? I saw some people having that number.
Yeah, I actually got that answer, but I had a question about how do we, like, does it matter what numbers we combine in a denominator? Because I combined 3 and 2 and I got 6.
Yeah, that's okay. It doesn't matter.
It doesn't matter.
Mm-mm.
And then the 1 just gets left alone, right?
Yeah, one is just there, right?
Okay.
Anybody else? Any question on this topic? Do you feel that you have a good handle of this topic, factorial, and you can manipulate expressions with factorials?
I think, yeah, I just have a question because, like, say we get a question like this, is there any other way that it's interpreted in, like, say, a word problem?
A word problem with factorial?
Yeah, or it would just be given like this, like as an expression.
No, you will have word problems with factorials, and those are coming up later in the lecture today.
Oh, okay, thank you.
That's why I'm getting you prepared for those word problems right now by making sure that the math part of the word problem is okay. You are all right with it. Then you have to understand what the problem is asking and then formulate it and solve it. All right. So let's go ahead and move on. Counting principle example, two independent events. One is buying a car. You can buy a car 5 different ways, and you can buy the insurance in 4 different ways. Together, how many car and insurance combination can you have? It's 5 times 4, which is what? 20 different ways. Next. So this is a problem a bit interesting. So let's say you have an access code, 6 characters. First 4 are digits. So you have an access code with 6 characters. First 4 are digits. And the last 2 are alphabets, which are case sensitive. So remember, they are case sensitive. If a thief trying to break this code has a probability of success. So basically it's asking what is the probability that a thief trying to break this code will get it right. There is only one code out of all the possible codes. So the probability will be 1 out of all the possible ways. 1 out of all the possible ways you could have this access code. Now, there are 6 characters in the access code, right? So you could think of it as 6 different events. Event A, event B, event C, event D, event E, and event F. You can think of it as 6 different events. Now, we know that the first 4 are digits. So let's start off with the first event. How many different ways the person can pick the first digit? What do you think? How many different ways can this happen?
10.
Okay, why 10?
They would be single digits, so 0 through 9.
Yes, thank you. Thank you. Is 0 through 9 or 10 different ways this could happen. So this is going to be 10 different ways. Now that you have picked one digit for the first character of the passcode, how about the second one? You pick another digit. Now, is that digit going to be dependent on the fact that you already picked the first digit? Is it going to influence the outcome of the second digit?
Yes,
Why?
because in the first, like in A, you already have 2 digits.
No, not 2 digits.
Oh,
This is the possibility. It's not that I have picked 1 and 0. 1 and 0 is the number of possible digits.
Okay.
Okay. Are you okay with it?
Yeah.
Okay. So now that you pick the first digit, one of the 10 digits, 0, 1, 2, 3, all the way up to 9, there are 10 digits, right? So you picked 1. So for the second one, how many options do you have?
Well, the word problem doesn't specify for digits.
What do you mean? It does specify, right? It says 4 digits.
So would it be 6 because 4 of them are in event A?
No. Only one was selected for A. Remember, there are 6 events. That means first 4 are selecting digits, and the last 2 are selecting alphabets. So you just selected 1 digit. You have 3 more to go.
9.
Okay, why 9?
Because you chose 10 already, so that leaves you with 9 other numbers if it's 1 through 10.
Okay, good, good argument. However, does it anywhere say that when you're selecting an access code or password, you couldn't repeat the same letter or same
So
number?
it would be 10 again?
Yeah, it would be 10 again.
Okay.
So 10 different ways. So event A can happen in 10 different ways, and event B can happen in 10 different ways independently. They don't influence each other. Then together they can happen 10 times 10 or 100 different ways. Is this clear?
Yes.
Yeah.
This is the fundamental counting principle or counting rule. Event A can happen in M different ways, and event B can happen in N different ways. Together, they can happen in M times N different ways. In this particular case, event A can happen in 10 ways. Event B can happen in 10 ways. Together, they should happen in 10 times 10 or 100 different ways. Now, let's go ahead and do the same thing. What about C? Still 10 digits, isn't it?
Yes.
So together, all of them could happen 10 times 10 times 10 different ways. Similarly, the last one, another 10 different ways. Together, they can happen in 10 times 10 times 10 or 10,000 different ways. So we have selected 4 digits, okay, for the first 4. We have selected 4 digits for the first 4. Now, E and F, those are going to be alphabets. How many ways can you select E? Not E, event E. So how many different ways you can select an alphabet?
26.
26.
26. Good. But remember, I said it's case sensitive.
Times 2.
Times 2, which means what?
52.
52. So this could happen in 52 different ways. And the last one could also happen in 52 different ways. And if you multiply all these numbers, I think you get 10,000 times 52 times 52. That is going to be 2704 followed by 40. Roughly about 27 million different ways. To be precise, 27,040,000 different ways one could select access code. Now, out of all of them, yours will be one particular one, right? Yours will be one particular one. So if a thief is trying to break and access your code, access your account, then the thief has about 1 in 27 million chance of being successful, right? Roughly about 1 out of 27 million. It's like one to be precise, 1 out of 27,040,000. So that's what it is. Now, remember, we have used the concept of fundamental counting rule, okay? And events being independent. All these events are independent here. Events A through F, they're independent events. One does not influence the outcome of the other. Okay, any question, anybody? Is it okay with everyone? All right, so let's move on. Now I'm gonna give you an example, okay? Here is an example for you. I have 3 balls. One is a red ball, one is a green ball, one is a blue ball. or blue box, red box, or green box, doesn't matter. So you have 3 balls, red, green, and blue. These are 3 different balls. Now you need to pick 2. Pick 2 out of these 3. Pick 2 out of these 3. How many different ways you can pick 2 balls out of these 3 balls? How many different ways can you select or pick 2 balls out of these 3? So I want you to work on this problem. How many different ways can you select 2 balls out of 3? Remember, what would help you to think about this problem is the baby problem. We have had couple wants to have 3 babies over 3 years. So you kind of could work along that line. That would help you solve the problem. So you are selecting 2 balls out of 3. All right. All right, there's a comment. Yeah. Yes, you are correct. Azucena, your answer is correct, okay? But let's go ahead and everybody try it. So I'll give you just a minute. All right, guys, so what do you got? What answer did you get? Please share your thoughts. Anyone?
I got 6.
Okay. Anybody else got anything else? Well, let's try this. One of the questions I was expecting that someone would ask, which is this. I'm picking 2 balls out of these 3. Does order matter? How I pick the ball, does order matter? If order does matter, then you're going to get certain number of pairs or certain number of ways to pick the 2 balls. If order doesn't matter, then you will have a different number. So that's very important. So first, let's assume that order matters. Order matters, meaning that picking red and green is not the same as picking green and red. Picking green and blue is not the same as picking blue and green. Picking red and blue is not the same as picking blue and red. So there are 6 different ways of doing it when order matters. So order matters this scenario. If order does not matter, if order does not matter, in that case, what happens? RG and GR is the same thing. RG. GB and BG is the same thing. GB. RB and BR is the same thing. All right. So these are the things. So they merge into one. So if order does not matter, you have three options. If order matters, you have 6 options. So that's what it is. Now, when you are collecting or arranging items in a certain way, or you are picking certain number of items from a set of distinct items, if order matters, what you are doing is called permutation. You are permuting the items. Permutation. On the other hand, if the order does not matter, you are doing combination. If the order does not matter, then you are doing combination. So it is permutation versus combination. So what we are doing, we are selecting certain number of items, in this case, 2 items, from a group of 3 distinct items where order matters. That is the definition of permutation, okay? You're picking 2 items from a distinct list of 3 items where order matters. It is called permutation. On the other hand, when you're picking 2 items from a list of 3 distinct items, when I say distinct, I mean 3 different items, okay? Where the order does not matter, you're doing combination. Then there are scenarios where some of the items repeat themselves. So you have one, let's say if I had red balls, not just 1, but 5 of them, or green ball, 3 of them, blue ball, just 1 of them. If you have multiple copies of the same item, then these organizations change, but that's slightly advanced, so I'm not going to go over those. But we just need to worry about the basic permutation and combination. So now let me just remind you, permutation. Order matters, remember that. Order matters. Combination. Order does not matter. In one case, order matters. In another case, order does not matter. So there will be word problems where you will be faced with a scenario where you have to either use permutation or combination. In that case, you need to just ask yourself the question, does order matter or not? If it matters, then you're dealing with permutation scenario. If order does not matter, you're dealing with combination scenario. Is this clear to everybody? Permutation, combination, just the definition.
Yes.
Okay.
Yes, sir.
Now let's go ahead, and I do actually have official definition somewhere here. Here, permutation, the arrangements of R items from N distinct items, okay? Arrangement of R items from N distinct items where order matters. That's the permutation. And the arrangements of R items, okay? R items from N distinct items where order does not matter, that's combination. Now for permutation, there is a formula. If you have N distinct items, from that you select R items, we write N, P, R, okay? Permutation of R items from N distinct items, but you don't say the whole thing, we just say quickly NPR, okay? Is equal to N factorial divided by N minus R factorial. That's the formula. N factorial divided by N minus R factorial. For combination, we write NCR. Again, combination of R items from N distinct items. There's going to be N factorial divided by N minus R factorial times R factorial. N factorial divided by N minus R factorial times R factorials. So that's what permutation combination formulas are. Now let me just go ahead and give you a couple of examples. I think that's gonna help you. All right. So now let's go ahead and do this problem. A student committee consists of 13 members. They need to elect a president, a vice president, and a treasurer. How many different ways this can be accomplished? So you have a group of 13 distinct students, right? How many are you selecting? 3 of them, because someone needs to be president, vice president, another person, and a treasurer, another person. So there are 3 people that we need to select from a group of 13 people. So your N, the number of people or number of distinct items, is 13. And your R, whatever you're doing, permutation or combination, in this particular case, 3. Now, which one of these formulas would you use? Basically, remember, the problem is asking how many different possibilities for president, vice president, and treasurer from a group of 13. That's what they're asking. So in essence, you're selecting 3 people from a group of 13 people. Now, how do you figure out which route to take? Are you going to do permutation or are you going to do combination? So I want you guys to help me.
Combination? Because the
Combination.
order. Would we do combination? Because the order doesn't matter.
Okay. So you think order does not matter, right?
Yes.
Yes. Okay. Any other thoughts, anybody? Does order matter here or order does not matter?
I think it does matter because one person could either be the president and then in another scenario, he could be the treasurer.
Yeah, absolutely. Order does matter. So think of 3 positions, president, BP, and treasurer. If student X, Y, and Z becomes president, vice president, and treasurer, it's not the same as Y, X, Z, right? So kind of order does matter. So if order does matter, we are going to use permutation. So our permutation of is going to be for 3 items from a group of 13 items, or 3 people from a group of 13, which is going to be equal to 13 factorial divided by 13 minus 3 factorial. I'm just using this formula straightforward. My n is 13, my r is 3. So if, oh, I forgot the factorial here. So this is factorial. So 13 factorial, I could write it as 13 times 12 times 11 times 10 factorial. And in the bottom, 13 minus 3 is 10 factorial. Now you can see this 10 factorial and 10 factorial are gonna cancel. Now 11 times 12 times 13 is what? 11 times 12 times 13 is 17, 16. So 17, 16. So there are 1,716 different ways you can select a president, a vice president, and a treasurer from a group of 13 different people. Is everybody okay with it? Any question on this problem, anybody?
How do we get the 10 again?
Where do I get the 10?
Yes.
10 factorial, you mean?
Yeah.
In the denominator, look, it's 13 minus 3 factorial. So 13 minus 3 is 10.
Oh, okay. Yep.
Any other questions, anybody? No questions? Everybody okay? All right. Let's move on. Now, this problem, I kind of want you guys to spend a little bit of time thinking about it, okay? I want you guys to think about it a little bit. And what I want you to do is try it. So what this means is that you're going to be using either permutation or combination. And then think of 2 independent events. So this is a great problem where you're going to be using permutation / combination and fundamental counting rule. And I want you to spend a couple of minutes, maybe even 3 minutes, try solving this problem. Of course, I'll do it, but I want you to try it on your own first so that you get a feel for the problem and you get to ask me questions. Is it okay, everyone?
Yes.
Yes?
Yes.
Okay. All right. Go ahead and work on it, please. All right. So what did you guys get? So somebody give me some ideas.
Is it permutation?
Okay. Any other thoughts? Anybody?
Maybe combination because once you choose a number, it gets taken out of the next event.
Okay. Any other thoughts? Anybody? All right. Yeah. So what's going on here? We are playing the Mega Millions, right? That's a famous lottery and it's played all over the country. In Mega Millions, you select 5 numbers out of 56 numbers. 1 through 56, you select 5 without replacement. That means you don't put it back. And 1 number from 1 through 46 or out of 46 numbers. So you select 5 numbers from 56 different numbers and 1 number from 46 different numbers. The 1 number that you select from the 46 different numbers is called mega number. And the other 5 numbers are regular numbers. So for you to win the Mega Millions, you have to match the 5 numbers as well as the mega number. Then you win the entire amount. That's how it works. Now there are 2 things happening which could be thought of as 2 different events. Event A and event B. Event A means you select 5 numbers, okay? Select 5 numbers. And event B, you select the mega number. Event A, you select the 5 numbers, and event B, you select the mega number. And these 2 events, by the way, are independent of each other. That means whatever you do to event A, meaning selecting the 5 numbers, that is not going to influence the outcome of event B or probability of event B, because those are different set of numbers from which you are selecting the mega. So this is very important. Now, the next question you should be asking, I'm selecting 5 numbers out of 56 different numbers. Does order matter? Is order important? The order in which I select the 5 numbers, does it matter? What is your thought on this? Does order matter when you play lottery tickets?
Yes, it does.
Okay, why? Tell me, please.
Because they come out one at a time.
Okay, any other thoughts?
No, because it's random.
So you're saying order does matter or doesn't matter?
It doesn't matter because if we're talking about the lottery is random, isn't it?
It's random, but you could have random numbers selected and order matters.
I think it matters because only one set of numbers is the right one.
Okay, any other thoughts from anybody? Nobody else wants to talk? All right, so let's say 1 through 56. I'm just randomly picking numbers. You pick 5, then you pick 1, then you pick 56, you pick 13, and you pick 21. I just picked 5 different numbers. This is one way of selecting. Let's say somebody named John Doe. He selects 5, 1, 56, 13, and 21. Now somebody named Jane Doe, she selects 21, 5, 1, 13, and 56. Both of them selected the same numbers, but in different order. Is Jane Doe not gonna win the lottery? Or is John Doe not gonna win the lottery?
It's possible they could either win.
Well, what clarify that it's possible they could either win? Is that what you said?
Yes, because then the order matters for the possibilities.
See, does it matter? Somebody could pick the numbers in different way. It's not in what order you pick the Mega Million numbers. I mean, the Mega Million lottery ticket numbers. It's what numbers you pick. Just because John got the numbers in this order and Jane got the numbers in this order, it doesn't make a difference. Both of them are going to be winners. Both of them selected the same numbers. Have you ever heard in the lottery, they say, hey, you selected 5, 7, and 9, but you win, but the other person doesn't win it because he or she selected 9, 7, and 5 in the other order. Do you ever hear that? The answer is no. So the question comes down to, or the answer comes down to rather, that order does not matter in lottery. Absolutely no. It doesn't matter in which order you select 5 items from those 56 items or 5 numbers from those 56 different numbers. So order does not matter. So you'll be doing combination. So 56 C 5. And the formula is going to be 56 factorial divided by 56 minus 5 factorial times 5 factorial, which is 56 factorial over 51 factorial times 5 factorial. Now I can simplify it. 56 factorial, I could write it as 56, 55, 54, 53, 52 times 51 factorial divided by 51 factorial times 5 factorial is 5 times 4 times 3 times 2 times 1. All right. Now you cancel things, 51 factorial, 51 factorials. That goes away. Now let's go ahead and cancel things. 5 goes into 55 11 times. 4 goes into 52 13 times. 3 goes into 54 18 times. 2 goes into 56 28 times. So if I collect all these numbers, it's going to be 28 times 11 times 18 times 53 times 13. And if you multiply these numbers, you get, let's see, 28 times 11 times 18 times 53 times 13. That gives you 3,819,816. So the number of ways event A can happen is 3,819,816. Now, how many ways can you select B? Which is very easy. I mean, event B can happen. How many different ways event B can happen? That would be one item out of 46. So it's going to be 46 C1. That is going to be 46 factorial divided by 46 minus 1 factorial is equal to 46 factorial over 45 factorial which is 46 times 45 factorial divided by 45 factorial. These two cancel out, that gives you 46. So event B can happen in 46 different ways. So event A can happen in 3 million and change different ways. And event B can happen in 46 different ways. Together, they can happen in this times this. So there's gonna be equal to 175, 711, 536. 536. So there are 175,711,536 different ways you can play the lottery. There are 175,711,536 different ways you can potentially play the lottery. And out of that, by the way, there will be only one winner. That means there is only one number, winning number, out of all of these possibilities. So your chances of winning the lottery is, in essence, 1 out of 175,711,536. And that's a pretty small chance. Now, this is well, before I move on, any question, anybody, are you okay with it? Do you feel that you are comfortable, you are knowledgeable about this problem and you understand the process?
I have a question.
Yes.
For number A, on the denominator, you put 56 minus 5, but where did you get the other 5? Because I know that you picked 5 numbers, but I don't know where the other 5 is from.
5, 4, 3, 2, 1? You mean this one?
Yes.
So this comes from this 5 factorial. So 51 factorial, right? This one is here. So these two cancel out. Then 5 factorial left, which is 5 times 4 times 3 times 2 times 1. Are you clear on this or no?
Not really, because the top part where it's 56 over 56 minus 5 and then 5 factorial again. I don't know why there's 2 5s.
Yeah, I got confused in that too.
I think they're getting confused from
With the formulas.
yeah, the formulas for it. The different formulas for each.
Are you talking about this formula or you're talking about these numbers here?
The formula on the top.
So remember, formula for combination is you have n items, NCR, you're selecting R items out of it is going to be n factorial divided by n minus R factorial times R factorial. And in our case, n is 56, R is 5. So you just plug in those values because there are 56 numbers from which you select 5 numbers, right? So it's going to be 56 factorial divided by 56 and minus R 5 factorial times R factorials 5 factorials. If you simplify that, it's going to give you 56 factorial. 56 minus 5 is 51 factorial times 5 factorial. And that's how I get that.
But that's only for this one because we're using the combination.
Right. If you were to use permutation, you'll be using NPR is equal to n factorial divided by n minus R factorial. So depending on, that's why I asked you. You should be asking the question, is it a permutation problem or is it a combination problem? If it is a permutation problem, you'd be using this formula. If it were to be a combination problem, you'd be using this. In this case, that's why I was asking you John Doe versus Jane Doe. Does the order matter or no? The order doesn't matter in a lottery ticket. So you'll be using combination. Does that clarify your concern?
Yeah.
Yes. Yeah.
Okay. Good. Anybody else has any other question about this? No? Okay. So now this is a question I ask everybody. So I don't have much time, so I don't want to dwell over this question too much. See, there are roughly about 175 million possible ways of buying the Mega Millions, and each Mega Million is $2. Okay, each Mega Million ticket is $2. So 175 times 2 is 350 million, roughly. And many times Mega Millions go over $600 million easily. Okay, I think at one point it went to $1 billion, I think. So let's say if you know that Mega Millions are over 600 million or 700 million, doesn't matter, whatever, even make it 800 million. If Mega Millions are $700 or $800 million, how come people don't go to the local bank and say, hey, I want to borrow $350 million and I'm going to buy out all these tickets? If I buy out all the tickets, I'm guaranteed to win the lottery, by the way. If I buy out every different combination of this ticket or every different possible combinations of this ticket, I mean these lottery numbers, then I am guaranteed to win. So I could spend $350 million and buy all the combinations for this lottery ticket and then get the $800 million or $600 million, whatever it may be, and go back to the bank and say, hey, after 1 week, you come back with, let's say you are generous, you give the bank $400 million. Okay? And you keep the difference, the other 400 million. Or 200 million, whatever it may be. Why are people not doing it?
They don't have good credit for the loan.
Who is talking?
That was me. I was just kidding. The time that it would take to input all the
That's not a
answers is
problem.
too much.
No, you could literally write a computer program. It'll do it in a matter of maybe less than 15 minutes. It'll do it. And you don't even have to do it. If you have that kind of money, you go to the lottery issuer and say, hey, here is my total amount of money. I'm betting on every single number. You don't have to actually write it. If they see that kind of money, they'll be like, please, sir or ma'am, come in. So why are people not doing it? Quick, I gotta continue. If you go to the bank and you borrow $350 million and after 1 week, when you win the lottery, give them $400 million, that's $50 million profit in 1 week. They'll be like treating you like, I don't know how good. They'll be doing pretty much everything money can buy for you. They will fly you around the world on a private jet, or dine you at the most expensive and most best quality food, put you in the best hotel in the world. They'll do it. But why are people not doing it? It's true, right? You buy out all the tickets and you're guaranteed to win.
Because there could be multiple winners, so you're not you can't get the full amount.
Exactly. Good. Thank you. One answer, multiple winners. Let's say you're lucky. There is no multiple winner. You're the only winner. Still, what's the problem?
You have to choose between getting a payout or receiving it monthly, and then there's taxes you have to pay.
Perfect. Who is talking?
Susie.
Susie?
Yes.
Okay, Susie, you caught all the different points that I mentioned to the students. Thank you. Well, Uncle Sam is not gonna just let you walk with $400 million without charging anything, right? Uncle Sam loves you, so he's gonna take his share, which is, I think, gambling. This is considered gambling money. I think they may be taxed at a higher rate, but let's be conservative. Let's say roughly you pay 40% tax. Okay. But then again, there is another thing that you need to take into consideration. If you win $800 million, they're not going to give you $800 million. That is not the truth. If you're new to the lottery, you don't know it. They give you $800 million over 20 years, I believe. So 20 years, every year you get $40 million, okay? All right. Every year you get $40 million, so 40 times 20 is 800 million. So it's over 20 years. Now there is an option, what's called cash option. That means you're gonna get it right now. In that case, you won't get 800 million. They do something called discounting or discounted cash flow. If you were to give, if you were to receive $40 million each year for the next 20 years, they will discount that money by the current interest rate, and their interest rate is probably not what the Feds have. Probably they probably have higher interest rate. I'm not sure about that, but anyway, regardless of the point, when you discount this cash flow that is supposed to happen over 20 years, the present value of that cash flow becomes much less than 800,000. It could be like maybe 500,000 or something like that. I meant to say not 1,000, 500 million. Okay, it's not going to be 800 million, it's going to be 500 million. And then you see all these factors. And of course, if there is somebody else winning, then you're out of luck. So these are the reasons, these are the three main reasons why people are not going to the bank and telling them, hey, I'm going to win the lottery. But if somehow you can convince the lottery issuer that there will be only one winner, then there might be some people who might take that chance. But then again, if you already have $350 million, then you don't really care for, maybe you do, I don't know. That's a very personal thing. But even if you didn't have the money, if there was only one possible winner, I think people would try something like this. But because of these restrictions, you can't. All right, that's all for this. So let's move on. Sorry, couldn't become millionaire tonight, or rather multi-millionaire. Exactly the same problem. I gave it to you for practice. This is something I made up, Lucky Millions. This time you select four numbers out of 40 different numbers and one number out of 30. So your event A is going to be 40, C4 times event B is going to be 30, C1. And if you multiply these two numbers, that is going to be the total number of ways these Lucky Millions can be played. And then out of all these different ways that the game could be played, there's only one way will be the winning number. There is only one way you can win. So your chances of winning the Lucky Millions is 1 out of these numbers. Okay, that's what it is. Next. So some company fired 13 managers, and they also not fired 13 managers. They had 13 managers, some company. And I think I got this problem from some textbook, so I have to give credit to that person. And I don't remember who that person was. It's probably Triola textbook, maybe, possible. Anyway, so there are 13 managers in a company, and they laid off 3 managers with the highest salary. So they're saying, was there any discrimination based on their income level? Okay, because they fired 3 highest paying managers, or they laid off 3 highest paying managers. So now the question comes down to this. They fired 3 people out of 13, or 3 managers out of 13 managers. How many different ways this can happen? Okay. And out of all these different ways, there is only one way. Out of all these different ways, there is just one way where you can have all 3 highest paid managers. Now, again, the question comes down to, is there, do we need to consider order or not consider order? Is order important versus not important? Is order important when you get fired? Does it matter?
No.
No, it doesn't really. So you're gonna do combinations. So 13C3, there's gonna be 13 factorial divided by 13 minus 3 factorial times 3 factorial, which is gonna be 13 factorial. 13 minus 3 is 10 factorial, 3 factorial, which is 13 factorial is 13 times 12 times 11 times 10 factorial divided by 10 factorial times 3 times 2 times 1. This and this cancel. Now 3 times 2 is 6, right? This 6 goes into 12 2 times. So 12 times, 13 times 2 times 11 is going to be 13 times 22. I think it's 286. So there are 286 different ways you can select 3 people out of a group of 13. Now, out of these 286 possible groups, there is only one group that has the highest paid managers, 3 managers. So your chances of randomly selecting 3 managers and letting them go is going to be 1 out of 286. And that's pretty small probability. I think it's 0.34% or something like that. All right, so next. Again, the same thing, another problem. I just gave it to you for practice. So go ahead and do that. Now let's do the permutation and combination example here. How many different ways 7 people can sit in 7 different chairs? Okay, so you have 7 people, 7 different chairs. How many different ways can they sit? Obviously here the order matters, right? Here the order matters. So it is gonna be what? 7C7, which is 7 factorial over 7 minus 7 factorial, which is 7 factorial over 7 minus 7 is 0 factorial. So 7 factorial over 0 factorial. What is 0 factorial, guys?
1.
1. So that's going to be just 7 factorial. And 7 factorial is something you could figure out. Next, how many different ways can 5 people sit on 7 different chairs? Now, instead of 7 people, now we have 5 people. Again, the same thing. 7C5, which is going to be 7 factorial divided by 7 minus 5 factorial, which is 7 factorial over 7 minus 5 is 2 factorial, which is going to be 7 times 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. These cancel out, and whatever you get by multiplying those numbers. 7 times 6 times 5 times, so it's going to be 60 times 42. 7 times 6 is 42, 5 times 4 is 20, times 3 is 60. And you can multiply these 2 numbers, and that is going to be your answer. Is this okay? Now, this last problem with this group, I don't like the ordering, wording of this problem. It's not very clear. Even though I made the problem, I think there is room for clarification here. So let me tell you what I meant to ask you. 5 people are sitting 5 people are sitting again in 7 different chairs, okay? So now, how many different rearrangements are possible where order does not matter? How many different rearrangements of 5 people are possible where the order does not matter? In this case, order matters. In this case, order matters. Here, order doesn't matter. So this is gonna be 7C5, which is gonna be 7 factorial divided by 7 minus 5 factorial times 5 factorial, which is 7 factorial over 7 minus 5 is 2 factorial times 5 factorial. And let's go ahead and do that. 7 times 6 times 5 factorial divided by 2 factorial is 2 times 1 times then 5 factorial. This cancel out. 2 goes into 6 3 times. So 7 times 3 is 21. There are 21 different ways you can do that. Or 21 different groups possible. This should have been not groups of people, it should have been groups of chairs of 5, okay? Because you need 5 chairs for 5 people. All right, next, any question on this? Any question? All right, I think to be consistent with my other sections, I'm gonna stop here for the night. The next topic that I'm gonna cover is this, binomial distribution. So on Wednesday, I'm gonna cover binomial distribution. So let's go ahead and work on binomial distribution. Just look at the class lecture slides before you come to the class. If time permits, I'll do binomial distribution as well as Poisson distribution. And whatever I cover until Wednesday is gonna be on the midterm, okay? Whatever I cover until Wednesday is gonna be on the midterm, which is on Monday, October 11th. And make sure to go over the assignments, all the assignments that you have done. Look at these lecture slides, as well as read the course materials handout that I gave you. You should be pretty well prepared for the midterm. You should not have to worry about it at all. Okay, if you do the homework, go over these class notes and read the book a little bit, you should be good. Any questions, anybody?
I just have one question. Are you gonna have your extra help class on Wednesday?
Not so much extra help. After I finish the materials, if you have any questions, I'll go ahead and answer. Oh, you mean the never mind. Okay, now I know what you're talking about. The 1 o'clock one. Yes.
Okay, thank you.
Okay, I was thinking that you were talking about the regular class time. But even during the regular class time, guys, let's say I finish the materials and I still have time, and if you have any questions, I'll be happy to answer those. All right, anything else from anyone? If not, that's all for tonight. Thank you so very much. You guys have a wonderful night.
You too, thank you.
Thank you. Enjoy your
Thank
night.
you.